We'll start with this. Q is equal to Q1 plus Q2. Okay, where Q1 is C1V plus C2V. Okay, so what is common? C is common, so I'll take C1 plus C2 outside. Q is equal to C1 plus C2. We'll consider it as equation 2. Okay, and this as equation 1. So now what I will do, I will replace the two capacitors with the one capacitor, and I will name that capacitor as CP. Why CP? Because we are considering the parallel combination. Therefore, CP will be the replacement capacitor. Now, how can I write Q for the CP? How can I write Q for the CP? Q is equal to CPV. CPV. So consider this as equation 3. Now from equation 2 and equation 3, if I balance this, what I will get? CPV is equal to V into C1 plus C2. Right? V into C1 plus C2. V get cancelled. So what will remain? CP is equal to C1 plus C2. So this is the expression or the general expression for the capacitor in parallel combination. So if I consider n number of capacitors, Cp is equal to C1 plus C2 plus so on up to Cn. Okay, this is also a very simple derivation, but this is going to be your important derivation. So this is all about the parallel combination. So what I can see with this expression, the effective capacitance is equal to the sum of the individual capacitance. No reciprocal. In series we have reciprocal, whereas in parallel we don't have the reciprocal. So this was all about the parallel combination. Okay, so this was about the parallel combination, and we will understand the difference between the two combination, that is the difference between series combination and the parallel combination. I'll just read it out. Okay, I'll explain you, but I'm not going to write it. If you're making notes, please follow my voice and you can make notes, and anyway at the end of the chapter I'm going to provide you the notes. Okay, so in series combination what happens? Only one end is connected. One end of the capacitor is connected to the other end of the capacitor, whereas in parallel, so if it is your series and this is parallel, if you're going to write the difference, the first one is going to be only one end of the one capacitor is connected to the other end of the capacitor, whereas in parallel both the ends are connected. Okay, so in series, capacitance is always lower than the lowest. Okay, lower than the lowest, whereas in parallel it is higher than the highest. Okay, and next in series the formula is 1 by cs is equal to 1 by c1 plus 1 by c2 and so on up to 1 by cn, and in parallel it is cp is equal to c1 plus c2 plus so on up to cn. So this is the third difference, and the fourth is very important. In series combination the charge is same, whereas the potential difference is different. In both the capacitor charge is same, potential difference across the capacitor is different, whereas in parallel combination charges are different but the potential is same. Understood? Here charges are same, potential is different. Here charges are different, potential is same. So this is a very simple and easy session that we did today. Series and parallel combination, please practice, and this is going to be a favorite thing for the CET exam, because most of the numerical comes from the parallel and series combination, because you have it in your practicals, you have it in your theory, therefore you're going to have it in your CET. So just remember the expression for both series and capacitor and parallel combination of capacitors. Okay, so we'll wind up the class and we'll meet in the next class. Okay, thank you.